when I first met the law of gravity that I knew what gravity was. But nobody knows what it is. You see, the law of gravity is an explanation, but it doesn't tell you what gravity is. Newton realized that. But we feel that once you've got a law, then you have explanation in its totality. That is far from the truth. What you can do, of course, and it's wonderful, is just with Newton, without Einstein, you can land a person on the moon. You can make wonderfully complex calculations, but you don't know what gravity is. Wittgenstein thought, he put it very well. He said, the basic deception of modernism is the illusion that the laws of nature are explanations of the phenomena of nature. They're not, they're just descriptions. Now that ought to make us humble when it comes to what we mean by explanation, but there's more to come. And the more to come is this, that again people are told you've got to choose between science and God. Once you've got a scientific explanation, you don't need God. But that is to misunderstand completely what you mean by an explanation. Let me put it into another sphere. So imagine we've got a Ford motor car engine here, sitting. And I'm lecturing you on this engine, and I say, ladies and gentlemen, we're interested in explaining this engine. So I'm going to offer you two kinds of explanation. One is in terms of mechanical engineering and the law of internal combustion. The other is Henry Ford. Choose. Well, I hear some people laughing. That's absurd. Well, let's think about that a little bit. Because the law of internal combustion and mechanical engineering are an explanation of that nature. So is Henry Ford. Wouldn't exist without him. But what's the difference, ladies and gentlemen? It's clear that if you want a holistic description of that engine, you must have both. And you notice, by the way, that they don't conflict with each other. They don't compete with each other. They complement each other. The point being that Henry Ford, who was very real, is not a scientific explanation. He's a personal agent explanation. Now, it would be ludicrous, ridiculous, and absurd for me to say, because I can explain at the level of science how that motor works in terms of mechanical engineering and the law of internal combustion, I don't need Henry Ford, thank you. That would be silly. It seems to me it's equally silly to say, because I've got a law of gravity, because I've got the Higgs boson, because I've got this, I don't need God. Because God is not the same kind of explanation. He's no less real, of course. In fact, there'd be no universe for physicists to do physics in if God hadn't made the thing. Do we get that point? It's very important. These are simple points, actually, but they lie at the heart of a public confusion. And it's not only the general public, it's many of my scientific colleagues who don't learn to distinguish different levels of explanation that fit together. They don't compete, they don't conflict, but they give us a complementary explanation. So, go back to Lawrence Krauss's statement. The Higgs boson is arguably more important than God. My response to that was to say, for what? The Higgs boson is arguably more important than God if you're giving a lecture on subatomic physics and explaining how the particles fit in. But if the question is, how does the universe exist and which Higgs bosons come to be, then God is arguably more important than the Higgs boson. And at the end of my article, I risked being slightly cheeky because I'm Irish. In a sense of humour, I said, what shall we say about the Higgs boson? Well, I said, Higgs predicted it, CERN discovered it, God created it. We celebrate the first two, what about the third? And that's exactly the point. And I would want to argue that those three statements are all valid. They do not contradict one another. And that's why I'm delighted to be a scientist, because the little I understand so little. The little I understand just makes me rejoice because it gives me an insight into the genius of the Creator that stands behind this universe. Now, one of the very exciting things, now I'm very old, I gave that away. I told you I was here in 1966. I shouldn't have done that. But anyway, I existed a bit before that as well. I arrived in Cambridge in 1962. That was a very exciting time to do mathematics in Cambridge. Because at that time, the first evidence came in that there was a beginning to space-time. The so-called Big Bang theory, the standard model. And the evidence was coming in. Now, here's the interesting thing. Now virtually every scientist accepts it. But then they didn't. In fact, it was resisted. And it was resisted by some of the most distinguished scientists in England. The editor of Nature, which is the most famous scientific periodical in the world, said in his editorial, we must resist this idea of a beginning. Why? Because it will give too much support to people who believe the Bible. Now, isn't this interesting, ladies and gentlemen? I actually lived to see this, that you had a major scientific advance, for which Arlo Penzias, amongst others, got the Nobel Prize, resisted by a scientist because it was too close to what the Bible had been saying for centuries. And I raised this with Richard Dawkins in one of our debates, and he was not impressed. He said, look, come on. He said, either there was a beginning or there wasn't. There's a 50-50 chance. So what's the big deal? I said the big deal is, Richard, it wasn't settled by throwing a dice. It took massive scientific argument to get people to move away from Aristotle's view that the mass energy was eternal, the universe had always existed. It took massive scientific evidence because it was resisted. These things are not settled by guesswork at all. So, contemporary science now accepts, with many nuances that are very complex, that there was a beginning. I had the wonderful opportunity of debating Alan Guth a couple of years ago, who's the father of inflation theory. If you don't know what that is, that's all right. But it's something to do with what happened just after the Big Bang. And in the audience was Alex Valentin, very distinguished Ukrainian, now American mathematician. And I was talking about this notion of a beginning, and he referred me to his work. And it says this: it is said that an argument is what convinces reasonable men, and a proof is what it takes to convince even an unreasonable man. With the proof now in place, and this is very interesting, and he's writing it fully aware of theories of the multiverse and all of this, he says this: cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. I find that interesting. Some people say to me, you know, the Bible is useless because it makes no predictions. Well, I suppose I understand what they mean, but I disagree with them. It tells us that there was a beginning. It's been saying it for thousands of years. And I'm bold enough sometimes to say to my colleagues, you know, if we take it more seriously, we might have looked for evidence that there was a beginning much earlier than we did. It doesn't say a lot about science. It's not a scientific textbook. Of course it isn't. I don't teach algebra from the book of Leviticus. Nowhere. But it does talk about the origins of our physical universe, the same universe that science is talking about. And it says there was a beginning. Now, what's fascinating about that is this. Well, it's the question we all ask. What was before that, when that means anything? And now we get a chorus of people telling us that the universe came from nothing. Now, I wish now to talk about nothing. It is a very important topic. But I warn you, I'm going to do that. But before I do, let me just give you an insight into what some of the world's leading scientists said about that beginning. It's very interesting. Arnold Penzias, I mentioned before, and he is just one very remarkable person. And he talks about astronomy, leaving us with a singularity, a beginning, a universe from nothing, with such a precise fine-tuning that one could almost say that behind it there's a supernatural point. Alan Sandage. Alan Sandage is often regarded as the father of modern astronomy. He discovered the quasar. What did he say? He said, I find it quite improbable that such order came out of chaos. There has to be some organizing principle. God, to me, is a mystery, but is the explanation for the miracle of existence, why there is something rather than nothing. And this is the question. This is a key philosophical question, much loved by philosophers. But it's very interesting. Why is it that there's something rather than nothing? And if you're driven by your physics to claim that it starts with nothing, how do you get from nothing to something? Well, I'll tell you how they do it today. They redefine nothing. Now that to me is extremely interesting. You see, as a Christian, I believe that the universe didn't come from nothing. It came from the creative hand of God. But now if you reject the existence of an eternal God, we've got nothing at any level. And so you have to invent some way of solving it. Now, Stephen Hawking's book, the main question addressed is this question, why there's something wrong with nothing. And it was when I first read his answer to this that I thought extremely interesting. So let me share his answer. It goes like this. Because there is a law of gravity, the universe can and will create itself from nothing. Pardon? Let me say it again. Because there is a law of gravity, the universe can and will create itself from nothing. So because there is something, the law of gravity, the universe will create itself from nothing. Contradiction number one. That's astonishing, isn't it? But it's worse still. Because there is a law of gravity. Not gravity, a law of gravity. Do laws create anything? Newton's laws of motion, do they move anything? You see the billiard ball on the table. The law of motion doesn't move, a cue does. Hit that person.